We are given that sine x equals root 3 over 5 and x is greater than pi by 2 and less than pi. So since x is greater than pi by 2 and less than pi, basically x terminates in quadrant 2 because only in quadrant 2 x lies in this interval. So first I have constructed this right triangle OPQ using this given information, that is x is greater than pi by 2 and less than pi, and we are also given that sine x equals root 3 phi. That is we know that sine x equals according to Sokotova, it is opposite to x over hypotenuse, and this is given as root 3 over 5. So which means opposite side to x is root 3, and that's why I have marked this side length OP as root 3, and the hypotenuse is 5. Here OP is the hypotenuse, so I have marked 5 for OP. So we have to determine this unknown side, which is OQ. We can do this using the Pythagorean identity. That is, the Pythagorean identity is sum of the squares of two legs in a right triangle equals square of the hypotenuse. So we can write as OQ. This is OQ. I'm sorry, I just have to write this as OQ quantity square plus the side length, or this is another leg of the right triangle PQ square, and this equals OP, which is the hypotenuse square. Now let's replace OQ. OQ is the one which we have to determine. So I just write down this as OQ quantity square plus PQ. We know that it is root 3. So replace PQ by root 3, and this becomes root 3 quantity square. And this equals OP is the hypotenuse. So it is 5. So it becomes 5 square. Let's simplify and solve for OQ. So here we have OQ quantity square plus root 3 quantity square. This root and this power of 2, they will get cancelled. So we will have only 3, and this equals 5 square is 25. Now we can solve for OQ. This is OQ quantity square, and this equals we subtract 3 from both sides, so we get 22. Now we have to take square root to solve only for OQ. So this square root and this power of 2 will also get cancelled. So basically we get OQ, and this equals square root of 2. Okay, I have marked this side length OQ as we have determined as root 22 in the right triangle OPQ. Now I'm going to determine sine x. Uh, we already have sine x, which is part of this question, so we do not have to determine this. We'll determine cosine x, that is cos x, and this equals, according to Sokotova, it is adjacent to x over hypotenuse. And so this equals adjacent to x is OQ, which is root 22, and this is hypotenuse is OP, which is 5. So we have determined this cosine x, which is root 22 over 5. Now we can solve for this cosine 2x. I'm going to write down one of the formula for double angle of cosine 2x. So this can be written as 2 cosine squared x minus 1. So let's replace cosine x by root 22 over 5. Therefore, this becomes 2 times of cosine x is root 22 over 5, and this has to be quantity square minus 1. Let's simplify this. So this becomes 2 times of square root of 22 square is 22, and the denominator we have 5. So 5 square is 25. Therefore, this becomes 22 over 25 minus 1. Now we can simplify the first fraction. 2 times 22 is 44, and then 1 times 25 is 25 minus 1. This can be simplified. That is 44 over 25. I write down this one as 25 over 25. So we have common denominator. Therefore, this becomes 44 minus 25 over 25. And this equals 19 over 25. So we have determined cosine of 2x equals 19 over 25. Let's do part B. That is, we have to determine sine 2x. Before we start to do this, I just observed that I missed a negative while finding this OQ, because OQ is on the negative side of x. So this has to be a negative root 22. So I'm going to write down negative root 22 over 5 for cosine x. Now we can determine the sine 2x. So according to the double angle formula of sine 2x, this is equal to 2 sine x times cosine x. Now let's replace the values of sine x and cosine x. So therefore this becomes 2 times of sine x is root 3 over 5, and then multiplied with cosine x is negative root 22 over 5. So basically we just have to multiply the numerators and the denominators. So here we have this is a negative quantity for numerator. I can put this as negative 2 times of root 3 and root 22. This is over 1 times 5 is 5, 5 times 5 is 25, and this can be simplified. That is negative of 2 times of, this is root of 3 times of 22. This is over 25. That is these two will get multiplied, which is negative 2 times of 3 times 22 is 66, and this is over 25. So we get negative 2 times of root 66 over 25. Now let's do part C. That is, we have to determine tangent of 2x. So we can use this quotient identity. That is, tan x equals sine x over cosine x. So if we replace x by 2x in this identity, this will become tan of 2x. And so we have to replace this x also by 2x. So it will become sine of 2x over cosine of 2x. So tangent 2x equals sine of 2x over cosine of 2x. We already have these values which we have determined in part A and part B. So I'm going to replace sine 2x, which is negative 2 times of root 66, and this is over 25. This is for sine 2x, and this should be over the cosine 2x, which is 19 over 25. So I put 19 over 25. Now let's simplify this fraction. I put this numerator fraction as it is, that is negative 2 times of root 66 over 25, and then multiply with the reciprocal of the denominator fraction, that is 25 over 19. So these two 25s gets cancelled, and so we are left with negative 2 times of root 66 over 19. And so this is the exact value of tangent 2x.